So let's try and get an intuitive understanding of what we mean by a limit by first examining a function. Now, let's say we've got this function f of x equals x squared minus 4 over x minus 2. Now we know that x cannot equal 2 because our behavior of this particular function is such that at x equals 2, the function would be undefined. We'd have something over 0. Well, undefined is sort of the wrong word. We have 0 over 0, but what would the value be? Well, we might not be able to find the value as x equals 2, but we could find out what happens as x approaches 2. In other words, how does this function behave? And so a good way to get an idea of how this function behaves is just to substitute in numbers that get closer and closer to 2. So if we assume that 2 is somewhere here in the middle, 2 is here, what's going to happen with numbers that approach 2? So let's start with a nice easy one. Let's say what happens at x equals 1. Well, if we substitute in f of 1 right here, we let x equal 1, that means we're going to have 1 squared minus 4, that's negative 3, divided by 1 minus 2, that's negative 1. So that's going to give us positive 3 right here. Well, what happens at 1.5? Well, if we were to take f of 1.5, that means that we're going to have to take 1.5 squared minus 4 divided by 1.5 minus 2. 1.5 squared is 2.25. Oops, 2.25, not 225. Try that again. 2.25 minus 4 divided by 1.5, good Lord, 1.5 minus 2. All right, 2.25 minus 4 is the same thing as negative 2.75, pardon me, divided by negative 0.5. And if we look at what's happening right there, that is the same thing as saying 3.25. Okay? And we keep on going down the list. We say, well, what happens at 1.9? Well, that's really the same thing as saying 3.9. And if we tried 1.99, we'd find 3.99 here. If we tried 1.99, we'd get 3.999. And you see what the behavior is. It looks like the values are getting closer and closer to, well, you said it. It looks like they're getting closer to 4. Right? Y looks like it's getting closer to 4. Let's see if that's the same behavior from the right. What happens if we put in 3? Well, f of 3, that's 9 minus 4, 5, divided by 3 minus 4, that's 5. All right, a little bit of a different number. What happens at 2.5? Well, 2.5 squared minus 4 over 2.5 minus 2 is going to be 4.5. At 2.1, it's going to be the same thing as 4.1. And you can verify this by pausing and trying it out on a calculator or working it out on paper, preferably. 4.01 at 2.01 and 4.001. Again, it looks like, even though it's coming from a higher value, we're getting close to y equals 4 at this point. So it looks like our behavior of this function is equal to y equals 4. We have no assurance what's going to happen between 1.99 and 2.001. We could get more and more numbers, but even as close as we get, we never quite get to 2. Nonetheless, it looks like this is a well-behaved function, that what's going to happen. F of x is not defined at 2, right? Because if we were to try to substitute in 2 into our function, f of 2 is going to give us 2 squared minus 4 divided by 2 minus 2. That's 0 over 0. And by the way, in correct speak here, we're not going to say that's undefined. We're going to say that's indeterminate. Indeterminate. But the behavior is what's important right here, because the behavior of this graph is such that as x gets close to 2, y gets close to 4. And so we say the behavior of this graph seems to be that as x gets close to 2, y will go to 4.